Hello, looks like we're live. Welcome to the webinar today. I'm Mike Petersen with Loft Labs, Senior Platform Advocate, and I'm joined by Tom. Let me go ahead and let you introduce yourself, Tom. Let everyone know who you are and what you do.
Yeah, thanks, Mike. Tom Lapp. I'm a cloud-native field engineer with Portworx by Pure Storage. So I'm on the sales engineer side and work with our customers and in the pre-sales environment with proof of concepts and things like that, evaluating the platform.
So you get to do something new like every day.
A lot of different scenarios, absolutely. Yeah, run into a lot of interesting problems and challenges to solve.
That sounds fun. All right, yeah, this is interactive. So if you have questions while we're talking about stuff, feel free to post in the chat, and we'll try to answer those. We can do Q&A at the end, but if you have questions throughout, we can pause the demo. So we're gonna start off with a couple of slides, and then we're gonna have a demo, and then, like I said, we'll have some Q&A and everything. So I'm gonna give a little bit of background on what vCluster is, if you haven't seen vCluster and you're here for the Portworx stuff. But let me go ahead and get started. All right, slide one. Kubernetes clusters today. So they're incredibly expensive and high maintenance. This is kind of currently what the setup looks like. So there's no tenant platform isolation besides like namespacing. High risk tenant workloads can bring down, interfere with the platform stack. Tenants cannot be admin because the platform stack is owned by the platform team. So like if a user wants to install something, they can't necessarily install it unless they talk to the platform team. So there's a conflict because the platform team wants to standardize and the tenants want to use the newest version of something or test something new and newest version of MySQL or something like that. So you've also got a replicated platform stack. So say you've got like 3 clusters. Each user wants to configure and set up their own stuff, or the platform team wants to configure their own stuff. You've got this stuff replicated across multiple clusters, and that can get kind of expensive. It's inefficient because maybe they drift and there's a different version installed on one cluster versus the other, and it's high maintenance. So it's a nightmare to patch and upgrade everything and make sure that everything's the same everywhere. So this is where virtual clusters kind of come in. So one of the big selling factors is they reduce cost. So if we take a look at the left, we've got tenant workloads and 100 Kubernetes clusters and 100 platform stacks. So you bring in vCluster and maybe you can reduce those 100 clusters down to 100 virtual clusters and one actual physical Kubernetes cluster, because you're going to have like 100 namespaces and 100 different virtual clusters running within it. And then one platform stack that you can share up the stack to the virtual clusters. And we have a slide later on if we have some questions about like what does that look like. All right, so virtual Kubernetes cluster. So for secure multi-tenancy, you can reduce cost and simplify operations. So on the left-hand side, it's kind of what you're looking at now. Maybe you've got 3 clusters or 100 clusters. Each developer has their own cluster. Each prod and dev has its own cluster. You've got Cert Manager installed on each of them, maybe OPA and then Istio and then Vault. Well, with vCluster, you can have a single cluster. You can separate everyone into their own virtual cluster, which is like a namespace, and then installed into the namespace is a new API and stuff like that. And then you can share up Cert Manager or Istio or Ingress. Portworx, you can share up Portworx too, to where they'll have access to configure stuff within their virtual cluster, but it's really just configuring stuff on the base cluster. And then, so here's a look at the share. It's basically the same thing from the last one, just kind of showing you like how stuff's shared. So you can have secure isolation. So it isolates tenants from each other using an API. So it's not just namespacing. There's actually a different API endpoint for each user. So they're not accessing the base cluster API. They're accessing a level up, and they're accessing a K3S or K8, whatever you have installed for the virtual cluster. You can pick different ones. You got tenant autonomy. So tenants can be cluster admin inside their virtual cluster without being admin in the underlying cluster. So like say someone wants to install the latest and greatest CRD for anything, they can install it in their virtual cluster. It's not going to get installed in the base cluster API. It's going to be a level up in their API. You got clear separation of concern. So tenants own everything inside their virtual cluster, while platform teams own and manage the base cluster. So they can kind of pick like which ingress controller stuff they want to use, and they can share that up. Or if a user wants to try something new, they can try something new out instead. And like I said, we got the shared platform stack, so it kind of reduces the amount of clusters. So it's going to save you some costs there. It's going to put it all on one cluster, and then you can have multi-tenancy in a way that's a little bit easier to manage without having to manage everyone's permissions and stuff like that. It's efficient, so highly utilized shared stack that never runs idle. So the idea is too that you've got a lot more people running on this one cluster, so you're going to use a lot more of the cluster than if you give each person their own 3-node single cluster and they're just running something for development or or testing or something like that. So it's consistent, so enforces hidden standards across all vClusters, and then low maintenance. So it's consolidated platform stack that can be centrally managed. And then that's my information. Let me go ahead and pass it off to Tom. But if there's any questions, ask questions. We've got a diagram kind of showing what it looks like. But if you have more questions about vCluster, we'll have some getting started stuff at the end. But the real fun of this is going to be showing off a demo that kind of gives you an idea of how that looks with storage, which is going to give us stateful workloads instead of just ephemeral stuff. So Tom, let me go ahead and let you take over for this slide.
Yeah, thanks. So this is kind of just a representation of what the Portworx is going to look like on your Kubernetes cluster. In this case, working with vCluster, we're going to install Portworx on the host Kubernetes cluster, and we're going to create a storage overlay, right? So we're going to consume disk and volumes from the underlying worker nodes, and we're going to aggregate those all up together into a storage cluster on your Kubernetes cluster, and make that available to all of your application workloads that are running on that cluster. And in this case, also in your vClusters that are running on top of the host cluster. So we're able to consume, lots of different storage devices, whether it's a legacy SAN, if you're in the hyperscalers, the drives, the block devices that they provide, and things like that. And we add that level and layer of orchestration and scalability and things to your Kubernetes clusters that they bring to the application side. We bring that to the storage side. And so when you pair that with something like vCluster, where you're able to, orchestrate and scale clusters very quickly on a single host cluster, having Portworx there for the storage is going to allow you to provide that scalability on your storage side too. So that's kind of what we're looking at here with Portworx. So we're really looking forward to showing this off today.
All right, so we had a question from Robert. Does this work on EKS? Do the vClusters share the same AWS VPC CNI? So the demo is actually on EKS. Right?
It is, yes, absolutely. So yeah, our demo is in EKS, so this definitely works in EKS, and we'll see that there. All
right, awesome. Let me go ahead and demo time. So I won't read over all this, but basically we're going to see some how to set up Portworx with vCluster Pro, deploy a stateful application using Portworx, and then I don't want to give away everything that's going to happen, but this is kind of some information about what you'll see. So let's go ahead and bring up the demo from Tom, and then
all right,
I will mute up and then chime in with some questions as they come up. So if you have questions, yeah, feel free to ask questions. We can stop and answer them, and then I'll see if I can come up with some questions too for you, Tom.
Awesome, thanks. All right, so this is a recorded demo. So if we do get some heavy questions, not a problem to pause it. What we're looking at here is 3 terminal panes. On the left-hand side, I have our host cluster, and then on the right-hand side, on the top is tenant 1, and then on the bottom is our tenant 2. So we'll just go ahead and start this playing, and we'll just kind of talk through it as everything goes. So we'll take a quick look at our host cluster, which right here is an EKS cluster, 6 nodes, 6 compute nodes, running vCluster Pro. If we take a look at what vClusters we have currently running, we just have tenant 1. We're going to spin up tenant 2 here a little bit later in the demo, just to show you how quick and easy that is. But we're running tenant 1 right here. Also going to use our pixie-cuddle command. This is our Portworx sort of low-level command to inspect the cluster and things. So we're going to get a status on our Portworx cluster. You can see all 6 nodes of our Kubernetes clusters are members of our Portworx cluster, and they're each providing 150 gigabytes of storage to the cluster for a total of about 900 gigabytes. And then real quick, we'll just take a quick look at a volume list here. And you can see right now we have 1 volume. And this is actually our volume that our tenant 1 vCluster is using. This is where vCluster stores its state and information about your cluster. And we'll take a look at that now. You can see here's our namespace list. And we have our tenant 1 namespace. This is where tenant 1 vCluster lives. So if we look at everything in that, we'll see what we have. A couple of pods that are running the vCluster, along with some services. And then you can see our persistent volume claim that is being used by the tenant 1 vCluster to store state and things like that.
I got a question for you, Tom. So this is all the storage is on the the hosts on each one of the nodes, is there multiple different ways to set up the storage then? Like, do you have to have like a disk attached to the node, or like what's the best way to set up the storage?
Yeah, yes. So we are consuming the storage from the underlying worker node. And there's lots of different ways. We can either consume it from a legacy SAN, if you have that, attached, if you just have direct attached NVMEs or SSDs. And then in the cloud providers, the hyperscalers, we can actually, go out and provision block devices from those APIs and attach them to our worker nodes automatically, right? So when it comes to things like scale and growing your cluster, right, we can do that automatically. So in the hyperscalers, that's a really great feature. So whether it's EBS or managed disk in Azure or something like that, we can manage that all. Additionally, we can do tiered storage, right? And that, here we're just looking at, single EBS volumes, but you can tier your storage. You can have some really fast, like IO1 drives, and then you can just have some regular GP3 drives, and then you have that tiered storage, which would, allow you to, choose your disk performance, your storage performance based on your workload needs.
Awesome, thank you.
Yep. So we'll flip over to tenant 1 over here on the right and take a quick look at it. It's just a base vCluster install. Get nodes. You can see we only show one node right now. There's a couple of different ways that vCluster lets you pass in node lists, but we're just running on the default here. So all we see is the nodes that have workloads running on them. And then if we look at our namespaces, again, a very, very default set of namespaces that you see in a small Kubernetes installation. And so what we're going to do now is we're going to go ahead and install an application that uses a MySQL database. We'll zoom that window here, and a PVC for it. So this is a Pet Clinic is the application we're going to install here. It's a state-of-the-art veterinary management system. But you can see in this chunk of YAML here, we're going to create a new storage class using our Portworx CSI provisioner. And then we're going to create a persistent volume claim against that storage class for the volume. And then, a couple other standard services and deployments to deploy our MySQL application that's going to back this, and then as well as the Pet Clinic front end application.
So this is like developer 1 and tenant 1, and this is what they see. This is their workflow, right? Like if they're just testing something, obviously.
Absolutely. Absolutely. So you can see we've created all of our application objects, and we'll just take a quick look at them here. And you can see everything's starting to come up. Our pods are up and running. They're initializing. We have a service, a load balancer service to get to our front end of our application. And then we have our PVC. You can see our 8 GB PVC that we have bound against our Portworx storage class that we created. And inside of this tenant cluster, we'll take a look at our storage class. You can see we have one storage class that we just created, and we're provisioning volumes against. So while that's all still spinning up, we'll jump back to the host cluster real quick here on the left. We'll take a look at our storage classes on the host cluster, and you can see that we have our PX-REPL3 storage class from that tenant synced down into the host cluster, right? So this is something that vCluster takes care of. So it syncs that down, so it makes it available so that once you provision your PVCs inside of that tenant, they can be provisioned against that storage class on the host cluster.
And the cool thing about this is what you're seeing on the left-hand side is what a platform administrator or the administrator of the base cluster is seeing, right? Absolutely. And then on the right side, all the developer is seeing everything too, which you're going to show that obviously, but this is giving you a view of like what each level can see and how the separation happens.
Yeah, absolutely. Right. Yeah, that's a good point. So, right, just like all the other shared services that, vCluster is able to implement, right? We have, Portworx is sort of the shared service on the host cluster, and it's available in every tenant cluster, but it can be managed by the platform engineering team of the host cluster globally. And then the developer teams can use it inside of their tenants. So really flexible. So right now we're just going to take another look at our volume list. You can see we have a new volume this time, our 8 GB volume. And in that HA column, you can see that we have 3. So we're running 3 replicas, right? So we can run multiple replicas inside of Portworx. And that's how we achieve high availability, redundancy, fault tolerance within the cluster. we're going to inspect that volume here. And what we're going to look at or focus on here is the list of replicas. So you can see that we have 3 replicas of this, and they're all on different nodes, right? So in the event of node failure or node node replacement or something, we've got multiple replicas of that are available inside of the cluster, right? And allows us to do things like hyperconverged scheduling. So we have a plugin to the Kubernetes scheduler, as well as our own scheduler, that is going to allow us to advise the Kubernetes scheduler, if we have a pod that has a Portworx volume, hey, here's a list of nodes where that volume exists, and we can schedule that on one of those nodes, or at least attempt to, right? To make sure that we're getting the best performance, because that volume is right there on that node.
So this is day 1. I've just got the storage class set up for, on the nodes. And then I want to add a faster storage class. I can just configure that on the base node and have multiple storage classes. And then my users would set up a different storage class in their virtual cluster. Is that how it works?
Yes. And in that case, there would have to be some communication, right? Because we're going to have to give you things like either some labels to select the pool that you want to run on, or some IO priorities or some IO classes that we want to hit to get that. But yes, absolutely, you can definitely do that.
Awesome. I'm here to ask questions.
Yeah, absolutely. That's great. So back over on tenant 1. So we're taking a look at our application. You can see that it's now up and running. So we're going to go hit that load balancer URL and log in, or just bring up our application. And you can see, so we're going to go in and hit find owners, right? This is our veterinary clinic management. You can see it's defaulted to populating some records. And we're going to go ahead and add a record. So all these records are stored in that MySQL database that's being backed by our Portworx persistent volume. And we'll go ahead and add in this owner. And if we go back and do a find owner query again, you can see we've got a new owner in that has been added to the database. And then we'll flip back here to the tenant 1. And what we're going to do now is we're going to take a look at where that database pod is running. And what we're going to do is simulate a failure, right? So we'll zoom this window in, and you can see this is our MySQL database pod, and it's running on this 46208 node. So what we're going to do is jump back over to the host cluster, and we're going to cordon that node. And so when we cordon that node, after we delete this pod, it won't be able to reschedule on that pod. Now, in the event of a failure, or when you lose a pod, right? If you are, if you're running with either maybe a host mount volume or an empty dir, or just the ephemeral storage in that container, once that container is deleted and moves to a new host, a new node to get scheduled on, right? That data is not going to be available. If it was an empty dir or a ephemeral storage in the container, it's gone. If it was a host mount path, well, that host mount path is going to be empty on the new node because it was stored over on the previous node that you were running. So with Portworx, and we're just going to go through here and delete this pod, but with Portworx, because we have those multiple replicas inside of the cluster, right? Not only do we have it available in multiple places, right? We can schedule right onto another pod or onto another node, bring that pod up and have an exact replica of the data that it was using at the time the pod crashed, or was rescheduled, or the node crashed or something.
So we hear the question, is vCluster can use in production? Well, like this, yes, this is showing like a production use case. With storage, yeah, you can use it in production, right? Like, awesome.
Absolutely. Yeah, absolutely. So yes, if you're going to run, stateful databases and things like that on your Kubernetes clusters, you want to make sure that you've got a great persistent storage solution to run in production. So we've gone ahead and deleted this, and you can see we've rescheduled on a new node 3070. And if we look back on the left-hand side, you can see that node 3070 is one of the nodes that we had a replica on, right? So we've rescheduled that pod onto another node that has a replica of that data. We're able to consume it. And as you can see here, we go in and refresh our view of our application, and our data is still there. We didn't lose it. We didn't end up with a default set. We didn't have no records or anything like that. So, that just shows the ability to, move quickly. When we lose a pod, we have the ability to have this high availability, the redundancy, and the fault tolerance with Portworx and inside of your vCluster tenants. So what we'll do now is we're going to spin up another tenant because we only have one running right now. We're going to create a second tenant, and we're going to do this through the vCluster Pro UI. And this just going to call him tenant 2 and using a PX vCluster template that I created. And you'll see just how quickly these vClusters come up. This one comes up in about 20 seconds or so. We'll flip back here to the host cluster, and we'll take a look at our namespaces. You can see we've got a new tenant 2 namespace that has been created. And if we look inside of that, we'll see, all the same things we saw in tenant 1, right? So we'll see some core DNS, our vCluster tenant pods, as well as you can see, again, a persistent volume claim that is storing the state of that vCluster, right? If we do a vCluster list, we'll see that we have tenant 2 listed. It's up and ready. And if we flip over to the web UI, we'll see again, the same thing, status ready is reflected. It's a vCluster Pro tenant. So we'll hop down to tenant 2 now and just take a quick look at it. Again, it's going to look very similar. You can see we only show one node. It's sort of the default listing, syncing in of node lists. We'll look again at the namespaces. Again, a default set of namespaces. You'll notice our pet clinic namespace isn't in here, because this is a wholly sort of separated cluster, right? The vCluster separates all those tenants, and they're running their own, cluster inside of the host cluster. So you don't see anything that doesn't exist in your cluster. So in this, we're going to deploy another application. In this case, it's going to be a Postgres. So we've got a couple of YAML files here. If we take a look. So we're going to go ahead and get started with deploying a storage class, another storage class. So this is the last time we had all of this stuff into one giant YAML file. This time they're all kind of individual. So we'll go ahead and create these. So we've got a new storage class. Notice so demo temp is in it. So we kind of use that as an identifier. And then against that storage class, we'll create a new PVC for our Postgres database. And you can see it there. It's bound right up, nice and quick. And it's a little 1 gig capacity PVC. And then we'll take a look at some things on the host cluster. Again, we'll look at our storage classes again. You can see that our new storage class has been synced down again, so that when we create PVCs against it in the vCluster, we're able to provision those on the host cluster through Portworx. And if we look at all of our PVCs, you'll see that we have our new 1 gig PVC that we created for our Postgres. And then we'll take a look at the volume list inside of Portworx, which is going to be very similar to our PVC look. So you can see we have 2 5 gig volumes. These are our core or our volumes that are backing vCluster to store that state. And then up at the top, you can see we do have that 1 gig new PVC that we created for our Postgres. And again, you can see that there we have, again, HA3. So we have 3 replicas of that. We'll go ahead and inspect that. And once again, you'll see that we have the 3 copies of it on 3 different nodes, right? So that's, again, we're providing that high availability, that fault tolerance, and resiliency inside of the cluster with that volume. So we'll flip back into our tenant, and we'll go ahead and deploy our Postgres application, right? That's going to consume that. And we'll see that pod comes up and running pretty quick. And now we'll take a look at, we'll describe it so that we can take a look at the mounts and the volumes that it's using. So we'll scroll up here and you can see in our mounts section, right, we have inside of var lib Postgres, right, where we're mounting our data. We're mounting it from a volume called Postgres DB. And if we scroll back down here, we'll find that volume, Postgres DB, and you can see that it's mounted from our persistent volume claim inside of our vCluster, right, that PX Postgres PVC that we created. So our pod's up and running. Postgres is ready to use. If we look at our storage classes, you can again see, we see only our storage class, right? This is the one that we created, our demo temp one inside of tenant one. If we look at our PVs and our PVCs, again, we only see one. We see the one that we have created inside of our tenant. And then if we jump back up to tenant one, and again, look for storage classes, right? We see our REPL3 up here. Note it's not the demo temp one, right? These are two separate storage classes that are isolated inside of each vCluster. We see our one PVC, and then we see our one PV that backs it, right? So what we get here is, this is vCluster providing that separation and that isolation of all of the cluster resources, all of the cluster projects and things like that. But with with Portworx then being that shared storage layer underneath that can get shared up into all of the tenants that you're running on vCluster. So
yeah, it's cool because you basically have taken an EKS cluster, and instead of creating another EKS cluster for developer 2, you've created a virtual cluster within it, which can now share the same ingress, right? So you've got one load balancer set up, and you're sharing that to all of your tenants. You've got one thing of storage, you've got one, cert manager, all of these things you're only installing once. And instead of getting a new EKS cluster and paying for that overhead, you've literally created 2 new API endpoints, and you don't have to give your users access to the EKS cluster. They have a new kube configuration for each of these vClusters that they've got set up.
Right. Yeah.
They don't even know that they're on EKS. I mean,
Absolutely.
They don't know where they are. They know that they have a full Kubernetes cluster and they can install and set up stuff like they want.
Yep, absolutely. They have all the services and features they want, and you've got the ease of management on a single host cluster where you're managing all of those services like the cert manager, OPA, Portworx, right? So you have, that global oversight and management ability on the host cluster, and your tenants are still able to, consume and use and run their stateful workloads, right? So, what we've shown here is, and what I think is really great is, the speed with which you can spin up a tenant, right? Tenant 2, we spun it up in about 30 seconds, and we're right into it, and we're deploying a Postgres application, right? So we've sped up our developers' ability to move, right? They don't have to wait for storage to be provisioned because that might come from another group. They don't have to wait for a database to be provisioned because that might come from another group, right? You don't have to give them RDS credentials because they don't need to do that now. So you can keep your costs down in that way too. So lots of different, benefits that we get from this. But I think the biggest one is, the ease of management, the scalability, and the fact that, our developers are now going to be able to really move at speed without being, waiting for services and storage and things like that to be provisioned.
So I have some questions then. So since we're kind of going to like Q, that was the end of the, I think that you have about another minute.
Yeah, that's pretty much everything that we were going to look at there. So yeah.
So what's one of the most common, like when someone starts coming to Portworx, like what's a common configuration? Is it per node, or do they use cloud storage, or do you see more on-prem stuff? Like what are you, day-to-day is different, right? Like, but is there a common thing that you're seeing with like storage and Kubernetes? Like what do they want, or what are they deploying?
So we see, I'd say right now it's about 50-50. We have a lot of people in the hyperscalers, running EKS, AKS, GKE. But we do have a lot of on-prem OpenShift is what we're seeing. So that's, I'd say it's about 50-50.
Do they ever ask you about multi-tenancy when you get to that point, or are you just like installing it like per cluster, or are you installing like a big storage pool and the clusters are kind of accessing it more, right? Like,
yeah. So we usually don't get the multi-tenancy question because we're usually not the ones helping them with their Kubernetes.
Okay.
Right. So that question doesn't usually come to us. Occasionally we'll be, if it's early days when they're, greenfielding Kubernetes and getting ready to run, we might be involved in those questions because they know that they're going to want a storage solution and they're thinking about how to do multi-tenancy. But it really just depends. But that question usually goes more towards their Kubernetes implementation team or implementation consulting group partner that they're working with there.
Awesome. All right, let me bring the slides back up and I'll show off just kind of some architecture, since maybe we'll have some questions about this. So if you have any questions, this is kind of Q&A time, a little bit extra. We're going to go over a couple of the slides and show like where Portworx fits in. So this is our monster of a display on this. It can be kind of confusing if you're first coming in, but this is the architecture kind of overview. And if you look at what we did previously, this is without Portworx. This is just kind of talking about like the admin, which is the like base cluster, and then the tenant. It kind of shows you what's running up above. So you have like an API server with the data store, and the data store is where the storage comes in, especially if you want redundant storage and you want to save the state of that virtual cluster for some reason as well, which we do have people running vCluster in HA mode. This will make it easier, right? Then we have like the syncer, which will actually take information and sync it down to the base cluster, because we're not doing reconciliation or anything like that. Let's look at the Portworx. So here, I'll go back and forth a little bit. You can kind of see how Portworx kind of fits in, right? So we've got Portworx now in the virtual cluster, and then we've got the sync Portworx PVC in the base cluster, but everything's really getting created on a base cluster. We say virtual cluster, but it's not a hypervisor. It's kind of obscuring the fact that they're running stuff on another cluster, and we're using Kubernetes power to actually do everything. Like everything's being done by Kubernetes still. We're just kind of scheduled, or we're syncing stuff to it so it gets scheduled. This might be a little bit confusing to people too, but let me go to the next one. If you want to actually talk to maybe this slide a little bit.
Oh yeah, this one gets to be a bit of an eye chart. So this one is this is sort of maybe just a more detailed version of the first slide we looked at from for Portworx. But it really shows, this really is sort of meant to show off that, we can, work with really any storage layer that you have, right? Any block device provider, whether it's coming from, a locally attached disk, legacy SANs, things like that, or the hyperscalers with their block devices and things like that. It's, all the different features and functions. We didn't, we looked at some pretty basic volume provisioning and things inside of vCluster with Portworx. But, Portworx the Portworx Enterprise Suite brings, a bunch of enterprise features and functionality to the table for storage. The things that you expect to have in, nowadays when you're running in virtual environments and things. So things like snapshot, volume lifecycle management, disaster recovery, application migration, volume migration tools, backup and recovery, and things like that. We have a tool called Autopilot, which is a rules-based engine that allows you to monitor your persistent volume claims, and as they get full, will automatically grow them and scale that that volume in real time with no downtime and things like that. So we've got this just-in-time sort of, I like to call it just-in-time provisioning of storage and things like that. So we bring a lot of these enterprise features that and functions that everyone's used to with their storage layers now, and we just bring that into the Kubernetes cluster and make it available. And we run on any Kubernetes distribution, any infrastructure, whether it's bare metal on-prem, whether it's any of the hyperscalers or things like that, whether your Kubernetes is vanilla Kubernetes, whether it's OpenShift or Rancher or any of those, we run on all of those Kubernetes platforms. So kind of we fit everywhere, and we bring those features like migration and disaster recovery to that multi-cloud hybrid cloud sort of target or goal that a lot of companies are reaching for. So if you're running OpenShift on-prem and you need to DR to EKS at Amazon, we can handle that. So we can go from one to the other, back and forth, whatever you want.
So do you have this configured in a home lab, or are you usually doing this on like EKS or something? You play around with it at home? And
I don't really run it at home. I do occasionally spin something up at home. We have a pretty nice lab that we have available to us. So
Awesome.
I'm often in the lab, using that. And then we have access to all the cloud provider platforms, right? So this demo I spun up in EKS and was able to run it in Amazon. So.
I'll say for people wanting to just try it out, try it in your home lab. You can do a little POC at home and then take it to work and say, hey, look at this. This is pretty cool. We'll
Absolutely.
run stuff at home redundantly.
Yeah. Right? You can totally run it in a home lab. We're pretty lightweight compared to some of the other solutions that are out there. If you have enough horsepower to run a 3-node Kubernetes, 3-worker node Kubernetes cluster at home, adding Portworx in is totally possible.
It's like home lab, work lab, like you just need a couple of like an extra drive or something like that per node, and then you can just give that drive to them, and you can get a lot more storage if you want.
Yes.
All right, cool. Well, I said thank you so much for the demo. The demo is awesome. It's recorded. If you want to watch it again and go back or see it later or share it, it'll be on here. We'll share information about how you can watch it too, especially if you signed up for the webinar. But so here's some next steps. So basically getting started with Portworx and vCluster. So Portworx docs.portworx.com, Portworx Enterprise, that's what we're showing off today. Central.portworx.com. What's central.portworx.com?
Central it's sort of our hub of operations for all of the things Portworx, right? So it helps you get started with documentation, links to documentation, links to interactive tutorials, and things like that. So we have some like live labs that you can do that will spin up, and you can do things, install Portworx, go through, spinning up applications, things like that, as well as help you get started building the spec files to deploy the Portworx cluster.
Awesome. So we had a question from Robert again. Any IO performance differences in vCluster versus the host? So everything's still running in the host. So you're not really going to see performance issues or anything like that. The only thing that's going to add to it is like you're going to have like another pod overhead for the virtual cluster. Now with the Pro version, you can move that overhead to a like controller node and then just run your workloads. Like say you're doing GPU stuff, you can just run your workloads on the node. But it's not really performance difference because these pods are still running on the base cluster. They're not actually virtualized with a hypervisor or like a layer up or anything like that, Robert. All right, and then so I'll go to the vCluster. So everything we showed today was vCluster Pro. Like I said, with the Pro, it's got some additional features and stuff. You can go to vcluster.com/pro, and then Pro Docs getting started install. And I believe there's a free trial, so you can get started and try it out. It's got the UI. It's got a different image behind vCluster Pro, and it's got some other neat features and stuff that you can use beyond the open source version. But you can try the open source version too if you want to mess around with that. vCluster.com. And the docs are just without the Pro on there. But yeah, so everything on here was Pro. The UI is Pro. It kind of makes it a little bit easier to install places, and you can actually get going pretty quickly if you just use the default like hosting that comes along with it too that we provide. But I don't know if we have any other questions, we can answer them. If not, like I said, this is going to be recorded and you can watch it again later. Ask questions on LinkedIn. You can put some comments on there or any of our other social media. But thank you so much, Tom. Do you have anything else you want to share or talk about before we head out? Oh, we got another question. Any storage level encryption support, especially via services like KMS or equivalent?
Yeah, absolutely. So we provide the ability to encrypt storage 2 ways. One, you can encrypt all the storage with a global key. So every volume that gets created would be encrypted with a single key at a cluster level. But we also do support per PVC encryption with a bring your own key, right? So your different application teams can encrypt their volumes inside of their namespaces that they're developing in with their own keys. So we do support that. Yes.
I have a question too. Like,
great question.
For on-premise stuff, do you usually see one large storage pool, or do you usually see it like broken up, like siloed in different teams and stuff too? Like, what's the largest amount of storage you've configured for Portworx for like a POC or like?
Yeah, for a POC, I think the largest one I did was up around 100 terabytes.
Okay.
And that was a pretty large cluster that somebody had, and they were testing lots of different options, lots of different cluster configurations, and they were rebuilding it about every 2 weeks. So they had it. It was, and so we built that one, and that one was pretty cool. As far as our, biggest and things like that, I don't, because I'm on the pre-sale side, I don't really get involved in the actual implementation side. So I don't see a lot of those bigger production clusters. We're usually working a little bit smaller scale with, the pre-sales teams and things.
Yeah. So. But maybe it's scaled to petabytes somewhere. Someone has it.
Oh,
right?
Yeah. Oh yeah, for sure.
All right, awesome. Well, yeah. Did you have anything else you want to say? We have another question.
No, thank you so much for having me. This was great. hope everybody is really excited about the possibility of running, persistent workloads inside of vCluster after seeing this. Go home and try it out. That's what I always do after a webinar.
Oh, yeah, I forgot to put on there. Join our Slack too, slack.loft.sh. You'll be able to find that information like on our LinkedIn and stuff too. And if you have questions, ask us, and I can get in touch with Tom if you have questions about Portworx. But if you have vCluster questions, join in and ask us. But thank you so much for joining. And like I said, if you have more questions, post them on LinkedIn, post them somewhere else, and then we'll share the video and stuff later, especially if you want to share it around your team. But thanks so much. Thank you so much, Tom. Thanks for coming.
Thank you. Thanks.